Hello everybody, and thank you for your interest in our course in quantum physics. In this first introductory video, I'm going to give you an overview of the course. I'll tell you about the course logistics, the grading policy, and we also will discuss in more detail the material that is actually going to be covered in the course. But first of all, I would like to introduce again the instructors, that is Charles Clark and myself, Viktor Galitsky. We both are theoretical physicists working on quantum science at the Joint Quantum Institute, or just JQI, at the University of Maryland. JQI is a very exciting place where there is a lot of wonderful science being done on a daily basis, both in experimental physics and theoretical physics. So there are a number of very talented students working with us, for example, these two guys here. And this, by the way, is a picture of a new building coming up where JQI will be located. Both the University of Maryland and JQI are situated in the Washington, D.C. area in the United States. So this is the beltway surrounding Washington, D.C. and this is the White House here, and we're about 5 miles or so from the White House. So we, the JQI, are always looking for talented students to work with us, students and postdocs. So if you are interested and would like to know more, please visit our website here at jqi.umd.edu. Well, you certainly can learn more about the JQI and about the science that we do by going to our website and searching the internet. We, on our side, unfortunately, know very little about you. So what we do know is that there are about 25,000 students signed up for our course, and that's it. So there is nothing else we know about you, unfortunately. Well, Coursera has your email addresses, and we can use this database to send you course announcements. But apart from that, we don't know anything about your interests, your expectations for the course, your future plans, and it would be very helpful for us to have a little bit of information about that. So we'd love to know more, and so in this context I would like to emphasize, please complete a survey that you will find on the class page on Coursera. It will take you maybe 30 seconds or a minute of your time to do so, but it will be very helpful for us to understand your expectations and also to gauge the level of the material that actually will be presented. So some of the lectures have already been recorded, but in the second part of the course, hasn't been recorded yet, and so this information will be really helpful. So now let me talk about the course logistics. So as you know, this is an 8-week course. There will be 8 weeks of lectures, 2 lectures per week, or well, 16 lectures total. I assume you can do the math here. So each lecture will consist on the average of 4 segments, 10 to 20 minutes each, and this will add up to about 2 hours of video content a week. So there will be 1-2 in-video quizzes in each segment. Those are not going to be graded, so this is sort of to keep you awake, to make sure you're still listening, and there will be 1 homework every week, which will be graded. So, and there will be 7 homeworks total, and in the last week we're going to have a final exam, which also will be graded. So I will discuss grading policy a little later. So one thing I would like to emphasize here, under this course logistics, is that there will be discussion forums, and you should definitely take advantage of these discussion forums. So if you have any questions or comments, or maybe you find a typo in the lecture, or you want to learn something, you have some suggestions, so please use the discussion forums. So first of all, your fellow students may be able to help you to answer some of your questions, or actually we also will be monitoring the discussion forums, keeping an eye on good questions and good students, and also actually we'll have a dedicated student on our side sort of monitoring the activity there. So use the discussion forums, it's very important. So a little more about our lectures. So just to remind you, this is a graduate / advanced undergraduate level quantum physics course, which automatically implies that there will be a lot of math involved. So, and also remember that both your instructors are theoretical physicists. We actually don't know anything else but math. So be prepared to see quite a lot of math. But on our side, we also realized that among the students who are registered for our class, so there are different variations in the level of mathematical preparation. So we tried to have different levels also in our lectures. So some videos are going to be pretty simple with no math involved. Some videos are actually going to involve pretty complicated stuff. So, and we came up with the sort of ranking of our videos by their level of mathematical complexity. So you will see maybe one or two video segments with 3 stars, which imply that they do involve very complicated math, and those will be sort of optional for everybody. So you don't have to watch them if it's not going to affect your final grade. So unless you're really interested and you want to go through the details, you can skip them safely. It's not going to affect it very much. But otherwise, I would encourage you, of course, to listen to all the material that we put together. Now, there will be quite a few lectures with 2 stars, which will involve the standard sort of quantum mechanics advanced math. So let's say differential equations, Fourier transforms, delta function. So these kinds of things are going to appear pretty often in the course. And in this case, for non-technical students, so I assume there are quite a few of you who don't really want to go through the calculations. You're just interested in quantum physics, you've heard something, you're interested, you think it's fun, you want to know a little more about it. So in this case, I would suggest that you definitely should skip the 3 stars, and you maybe should listen to the beginning of the lectures with 2 stars, which I normally will try to provide a summary of the results in the beginning, so that even if you don't understand all the calculations, you can still sort of get the main idea. So in this case, basically what I'm saying is that you can listen just to part of the lectures with 2 stars, and this would be fine. Now, there will be lectures with just 1 star, which will imply that there is some math involved, but it's not really crucial to understand the main results. So you may watch it, and it's not about math, it's about some other things. So, and finally, there will be lectures with no ranking in some sense. So those don't really involve heavy math, and anybody can listen to them, whether or not you have physics background or math background. You still should be able to understand. Now, let me say a few words about the material that we're actually going to learn in this class. So this is the syllabus page for our course on Coursera. So you can take a look at it. So it's available already. So let me mention first of all that we did not even try to cover all conceivable aspects of quantum physics in this 8-week online course. I don't think it's possible. So even when we teach our graduate students here, so already had some exposure to quantum physics, so it takes about a year for us to cover all aspects of quantum physics. And then there are some advanced courses on top of that. So it takes some time, to learn quantum mechanics at the professional level. But I think we have a very good selection of topics here nevertheless. So among them, I would like to emphasize this Feynman formulation of quantum theory that I personally like very much. I think it's one of the most elegant theories developed by Feynman in quantum theory. So, and in the 4th week, we're actually going to get to rather modern results, so-called quantum localization. So we're also going to discuss a little bit theory of superconductivity, which is another fascinating phenomenon which relies on quantum science. So Charles will start his lectures in the 4th week, and he's going to talk about a very important problem of hydrogen atom. He discussed atomic spectra and present a solution to the Schrödinger equation in the Coulomb potential. So it's a very important result. So he'll talk about symmetry and conservation laws in quantum physics. So later on, actually, we'll touch upon modern developments, more modern developments in quantum science, such as, for instance, the quantum Hall effect, and very modern developments, so-called topological insulators. Some of you might have heard about them. So, in the end of the course, we're going to talk about other interesting phenomena: time-dependent quantum mechanics, topological Berry phase, quantum optics, and lasers in the last week. So, the last lecture we sort of keep it open, so we don't know yet what's going to happen in the last lecture. So it will much depend on actually your interest, your response. Let's say if you request something in the discussion forum, so we may decide to cover it in the last lecture. So we'll see about that. But all in all, I think it's a very good selection of topics, and you're gonna learn well, the basics of quantum mechanics and also some advanced topics. So the last comment here I'd like to make is that, you know, when you read a new book on anything, so before you get to the action, you know, it takes some time to introduce characters, you know, and well, sometimes, you know, you may find it a little boring. And likewise, you know, before we can get to the action in some sense here in quantum mechanics, it will take me well, a few lectures to introduce the basics, to remind you or you know, tell you a little more about the history of quantum mechanics, how it was actually discovered, the main equations that govern quantum behavior, and tell you about the mathematical formalism. So, and I would encourage you to you know, keep with me during these first few weeks before we get to the interesting stuff, which is going to appear a little later. Finally, let me talk about the grading policy. So I assume that it might be of interest to many of you who would like to get a certificate of accomplishment. So the grading is going to be based entirely on your homeworks. So there will be 7 homeworks for each week. In the end of the week, there will be a homework. And these 7 homeworks are going to contribute 70% to your course grade. And finally, in the last week, there will be a final exam, which essentially is a long homework, which will cover all the topics we will have studied by that time. And the final exam will constitute 30% of the course grade. So each assignment will have a soft due date, where you will get the full credit for whatever you have done by that time, and a hard due date, after which no submissions will be accepted. So, and there will be some penalty, you know, after the soft due date, 5% per day, which is, I think, what's recommended by Coursera. Now, in the end, we are going to issue 2 types of certificates, either regular or with distinction, and the precise cutoff for those will be determined later. So it will be curved based on the performance of other students, but I would estimate that regular certificate cutoff will be around, let's say, 60% of the grades, so you will have to provide 60% of correct answers. And the certificate with distinction will be at about 90%. So, but otherwise, I think it will be pretty democratic sort of grading policy, and most of you who make an effort to complete the homeworks are going to do very well. Okay, and after all, if you don't want to do the homework, it's fine too. If you just want to listen to some lectures, of course you should feel free to do so, and we understand, of course, that you all have busy schedules and other things to do, so just have fun. Okay, and I'll see you in the first lecture soon.